Here's another quick example showing how to apply nodal analysis. So in this exercise, they're asking us to find the voltages at 3 nodes. So that'll be V1, V2, and V3. So here we would just set up our system of equations and then solve for that. So let's see how we do that. So as we look at the first one, V1 here, the first thing we note is a current source. So when we do nodal analysis, that means we're summing up all the currents entering and leaving a node. And we, by convention, typically define current leaving the node as positive. So in this case, a current source shown going into the node will be negative, so that'll be a -1. And then we see we have this resistor here, 2 ohm resistor. So by Ohm's law, then we can write the current going through there as the difference in the voltages. So it's V1 minus V2 divided by the resistance, which is 2. And that's all the branches going in and out of that node. So if we add those two together, that should equal to 0. So next, we want to look at this node here, V2. So let's write the equations for that. So first thing we see is we've got the 2 ohm resistor already highlighted. And so again, that's just going to be Ohm's law applied. So that'll be V2 minus V1, the difference in the voltages, over the resistance, which is 2 ohms. And then next, we have this 3 ohm resistor. And again, Ohm's law, easy enough, it's just the voltage over the resistance, so V2 over 3. And then finally, we've got this 4 ohm resistor here. And if we were to write that one out, that again is going to be the difference in the voltages, so that's V2 minus V3 over the resistance of 4 ohms. And so that's the 3 branches going in and out of that node. So we should be able to set that equal to 0. Okay, so that leaves us one final node here. So we'll represent that here, V3, or node 3, maybe we would call that. And we can see that we have 4 ohm already in purple, so let's write that. Again, Ohm's law, difference in the voltages, V3 minus V2 over 4. And then finally, we've got this resistor here. Again, another Ohm's law application. That'll be the voltage V3 over the resistance 2 ohms. Again, we set that equal to 0. So now we need to do some multiplication to get rid of all the terms in the denominator and then collect like terms. So if we were to do that for this first one, if we multiply through by 2, we should get V1 minus V2, and then move the whole number over, is equal to 2. And then for the second equation, if we multiply through by 12, we will get 6 times V2 minus V1 plus 4 V2 plus 3 times V2 minus V3. All that's equal to 0. And so then if we collect all our like terms here, it's only 1 V1, so that'd be minus 6 V1. Well, 6 V2 plus 4 V2 is 10, plus 3 V2 is 13, so that's 13 V2. And then we'll have minus 3 V3. That's all equal to 0. And then finally, for this guy, if we multiply through by 4, we'll have V3 minus V2 plus 2 V3 is equal to 0. Gathering like terms on that one, we will have minus V2 plus 3V3 is equal to 0. So here are our three equations with our three unknowns. So now it just becomes a linear algebra problem. We can write the matrices for these if you like. That would be 1, minus 1, 0, and then minus 6, 13, minus 3, and then 0, minus 2, minus 1, 3. Again, that's going to be multiplied times V1, V2, V3. And if we set those equal to the corresponding solutions, the first one was 2, which we get from here. Next one is 0, and then 0. And now, again, using most scientific calculators, you can do this, or you can apply your linear algebra knowledge. But we'll divide this matrix into this array. And when we do, we come up with V1 is equal to 4 volts. V2 is equal to 2 volts. And then V3 is equal to 2/3 volts. And so this is what was asked for in the problem expression. So this is our answer.